Okay, I think the other sessions are getting started. We did have a couple run late of our first session, so we give a couple extra minutes. I'm sure Chris will be able to deal with that. Good morning. My name is Blake Thompson. I own BET Broadcast Engineering, and I'm the ABIP inspector. So if you sign up for an inspection, you get me come out and rake over the coals on those little minor details that you thought you had right. At least that's what I hope to find, so that's part of the job. Our next session is called 5G Technology and the Future of Remote Broadcasts, presented by Chris Crump of Comrex. He's the Central U.S. Sales Manager and joined Comrex in 2004. Began his radio career in 1987 at ABC Cap Cities in Detroit before taking the features editor position at Media-Based Research Monday Morning Replay. He's been an on-air remote broadcast engineer, creative service director roles down in Florida. In 1996, he moved to the manufacturing side of the business and was a sales and marketing person for Spectral, Euphonics, Symmetrics, and Clocks Digital. He's got a wealth of experience before even joining Comrex. CBNE certified member of SBE Chapter 5 and responsible for new product developments in the category cabling space.
That's not me.
I didn't think so.
That sounds like, what's his name?
Yeah, I think they transposed somebody here. I'm like, wait, that's not right. That's got to be the guy from Belden.
Yeah, that's what I was thinking of.
But he is a longtime exhibitor, and Comrex sponsored your breakfast this morning. So I personally want to thank you so much for sponsoring breakfast.
Hey, I got to eat too. I really liked it. So
the coffee and the sweet rolls were great. So that's it. We're delighted to have you here.
Excellent. So we've been getting a lot of questions. Obviously, we depend on widely deployed data networks to basically allow our customers to get their remotes on the air. And it's the way we've always been. We've been kind of riding that wave of technology since we started in the 60s, using 26 megahertz frequency for IFB. That was one thing that we did. But we were able to actually harness telephone technology, POTS technology, first with autocouplers and hybrids, and then frequency extenders. Anybody have a single line, two line frequency extender in the shop, holding open a door somewhere? Yeah, okay.
In a cabinet.
In a cabinet. Anyone ever use a 3-line frequency extender? Remember those? Oh, yeah. Okay. So we've been exploiting all of these technologies for a long time. So when 4G came out, when 3G came out, we were pretty excited about being able to plug a modem into one of our new IP audio codecs and basically broadcast from anywhere you had a signal. That was kind of the holy grail, because previously you had to have a wired POTS line or an ISDN line, or you had to have a licensed frequency to be able to do a remote shot. But 3G was pretty exciting until you got out there with a bunch of other people that were using it as well, and you find out how it really didn't work overly well. But 4G was great, and it still is. 5G is driving me nuts, because people are asking me about, when are you going to be 5G ready, and So I went and did some research on 5G technology to find out what it was and what we needed to expect from 5G. And it was very enlightening, because there is what 5G is going to be and what it is, what the phone companies are telling us it is, and what it really is. And so in the spirit of not working any harder than I have to, I found this really nice presentation that was put together by the fine folks at IEEE Spectrum. And they asked me to promote it 3 times in any presentation I do, so I've done it once. IEEE Spectrum was really nice. That's twice, and I'll do it at the end too. But it's really an interesting piece of work, and I want you to take a look at it, and then we'll give you our take on 5G technology. But I don't hear it, which is a drag. Well, I heard it. Okay, we'll get there.
Every new generation of
I can
wireless
hear it
networks delivers
really low.
faster speeds and more functionality to our smartphones. 1G brought us the very first...
Okay, let's start again. Here we go.
Every new generation of wireless networks delivers faster speeds and more functionality to our smartphones. 1G brought us the very first cell phones, 2G let us text for the first time, 3G brought us online, and 4G delivered the speeds that we enjoy today. But as more users come online, 4G networks have just about reached the limit of what they're capable of at a time when users want even more data for their smartphones and devices. Now we're headed toward 5G, the next generation of wireless. It will be able to handle 1,000 times more traffic than today's networks, and it'll be up to 10 times faster than 4G LTE. Just imagine downloading an HD movie in under a second, and then let your imagination run wild. 5G will be the foundation for virtual reality, autonomous driving, the Internet of Things, and stuff we can't even yet imagine. But what exactly is a 5G network? The truth is, experts can't tell us what 5G actually is, because they don't even know yet. But right now there are 5 brand new technologies emerging as the foundation of 5G. Millimeter waves, small cells, massive MIMO, beamforming, and full duplex. First up, technology number 1, millimeter waves. Your smartphone and other electronic devices in your home use very specific frequencies on the radio frequency spectrum, typically those under 6 gigahertz. But these frequencies are starting to get more crowded. Carriers can only squeeze so many bits of data on the same amount of radio frequency spectrum. As more devices come online, we're going to start to see slower service and more dropped connections. The solution is to open up some new real estate. So researchers are experimenting with broadcasting on shorter millimeter waves, those that fall between 30 and 300 gigahertz. This section of spectrum has never been used before for mobile devices, and opening it up means more bandwidth for everyone. But there is a catch. Millimeter waves can't travel well through buildings or other obstacles, and they tend to be absorbed by plants and rain. To get around this problem, we'll need technology number 2, small cell networks. Today's wireless networks rely on large, high-powered cell towers to broadcast their signals over long distances. But remember, higher frequency millimeter waves have a harder time traveling through obstacles, which means if you move behind one, you lose your signal. Small cell networks would solve that problem, using thousands of low-power mini base stations. These base stations would be much closer together than traditional towers, forming a sort of relay team to transmit signals around obstacles. This would be especially useful in cities. As the user moved behind an obstacle, his smartphone would automatically switch to a new base station in better range of his device, allowing him to keep his connection. Next up, technology number 3, massive MIMO. MIMO stands for multiple input, multiple output. Today's 4G base stations have about a dozen ports for antennas that handle all cellular traffic. But massive MIMO base stations can support about 100 ports. This could increase the capacity of today's networks by a factor of 22 or more. Of course, massive MIMO comes with its own complications. Today's cellular antennas broadcast information in every direction at once, and all of those crossing signals could cause serious interference. Which brings us to technology number 4, beamforming. Beamforming is like a traffic signaling system for cellular signals. Instead of broadcasting in every direction, it would allow a base station to send a focused stream of data to a specific user. This precision prevents interference, and it's way more efficient. That means stations could handle more incoming and outgoing data streams at once. Here's how it works. Say you're in a cluster of buildings and you're trying to make a phone call. Your signal is ricocheting off of surrounding buildings and crisscrossing with other signals from users in the area. A massive MIMO base station receives all of these signals and keeps track of the timing and the direction of their arrival. It then uses signal processing algorithms to triangulate exactly where each signal is coming from and plots the best transmission route back through the air to each phone. Sometimes it'll even bounce individual packets of data in different directions, off of buildings or other objects to keep signals from interfering with each other. The result is a coherent data stream sent only to you. Which brings us to technology number 5, full duplex. If you've ever used a walkie-talkie, you know that in order to communicate, you have to take turns talking and listening. That's kind of a drag. Today's cellular base stations have that exact same holdup. A basic antenna can only do one job at a time, either transmit or receive. This is because of a principle called reciprocity, which is the tendency for radio waves to travel both forward and backward along the same frequency. To understand this, it helps to think of a wave like a train loaded up with data. The frequency it's traveling on is like the train track. And if there's a second train trying to go in the opposite direction on the same track, you're going to get some interference. Up until now, the solution has been to have the trains take turns, or to put all the trains on different tracks or frequencies. But you can make things a lot more efficient by working around reciprocity. Researchers have used silicon transistors to create high-speed switches that halt the backward roll of these waves. It's kind of like a signaling system that can momentarily reroute two trains so that they can get past each other. That means there's a lot more getting done on each track a whole lot faster. We're still working out many of the kinks with millimeter waves, small cell networks, massive MIMO, beamforming, and full duplex. In fact, all of 5G is still a work in progress. It will likely include other new technologies too, and making all of these systems work together will be a whole other challenge. But if experts can figure that out, ultra-fast 5G service could arrive in the next 5 years.
I did not program that into my presentation. That was really actually kind of cool. So thank you, Amy, for that. She was really good. Amy at IEEE Spectrum was very nice to let me use that and show it to you all. I could have done that easily, but why bother? So obviously the benefits of 5G technology are amazing. You know, 100 times or 1,000 times the bandwidth and 100 times the speed and super, super fast. But the problem is it doesn't exist yet. So as much as people really want, to know what we're going to do with 5G, we don't know because we don't have it. So the truth of the matter is 5G actually kind of exists. There is a fixed 5G that was fully specified at the end of 2017 in December, and that's deployed. We'll talk about that in a second. But if you believe these guys, it's right around the corner. It's going to happen any second. But again, you have to remember, CEOs have one job, and that's to get people to buy their stock and to say anything they can to get people to buy their stock. So everybody wants to be first. They've got really bad 5G-itis. So obviously Verizon wanted to be the first with 5G, so they went out and they used the fixed 5G standard, and they've deployed it in 4 markets right now. So fixed 5G is not mobile 5G, but they're using 5G, and that's all that really matters for the stockholders. I'm really curious about Randall Stevenson from AT&T because he says it's just going to be a software upgrade. Huh? If you don't have the radios and you don't have the silicon, how is it just a software upgrade? That just blows my mind. He also says that it's not going to be in mobile devices. He just made that announcement last week in a press release. They basically intend to sell it in MiFi hotspots, which I'm still scratching my head over that one. So I don't know what this guy is thinking, but I think he's just saying words. The guy from T-Mobile is really interesting because he says he's the only network capable of doing it, especially now after they've acquired Sprint and all of that 600 megahertz bandwidth, all that frequency that they got in the auction not that long ago. And he does have a point there, and it kind of validates our thinking on the topic as well. He also just recently signed a really big contract with Nokia for $4.1 billion to build their network. They don't know what they're going to be building it with, but they signed the contract, and that's the important thing. So, as I mentioned, a narrow scope for fixed 5G was released at the end of 2017. The markets that they're actually using it in are Los Angeles, Sacramento, Houston, and Indianapolis. Essentially, it replaces the need for fiber or Ethernet-based or cable-based broadband. It's basically a very narrow beam, and it's very high bandwidth. We're talking 300 meg to 1 gigabit of data speeds, super low latency. And it's a lot more efficient than digging up the earth and burying cable. And so that's good for Verizon that they're the first fixed 5G implementation. Telia over in Norway and Sweden is actually using it for cruise ships. because you have these giant cities floating on the water, and they're using giant C-band dishes on the boats out at sea. But when they dock, instead of running cables that could easily break because the boat is actually moving, they're using fixed 5G to provide them with all of their data connectivity when they pull into shore, which is kind of cool. And I think we'll see more fixed 5G in really populated areas. I think India is actually looking at it because of their massive population centers, and it's just impossible to bury anything there, cable-wise, I should say. So no silicon exists yet, there's no radios yet, and there's no handsets yet. So we're still a ways away. And as we learned in the presentation, they're still trying to figure out which technologies to use. There were some tests that were done with Qualcomm and Verizon, and Verizon again, with their big case of 5G-itis, said they made the first mobile 5G phone call on a Qualcomm device. And of course the device didn't look like this, it probably looked like this, or it was probably in a big briefcase, and it was probably really ugly with wires and circuit boards hanging all out, but they did it. So we know that they're moving forward with some tests of technology. And I think that AT&T said that they made a 5G test as well. So everyone's kind of working on it, but nothing has been fully specified because the full specification isn't due to be released until 2020. Now, the thing I'm confused about is I hear that they actually pushed it up and they completed the full specification in June of this year, but that's not the case. So everyone's got different information. The real information is 3GPP hasn't released the final specification, not due until 2020. But they're still pushing forward with the technology. And there is always a lot of PR about 5G and development, so we're going to continue to hear about it. I would not really anticipate full deployment until 2024 for 5G. So for us, 5G isn't necessarily just using the 300 gigahertz to 300 gigahertz frequency. Now, she made the point that that range of frequencies has not been used for mobile. The fact of the matter is it's still got a lot of stuff in there. There's a lot of industrial science and medical technology that are using those frequencies. The other thing that isn't really discussed by the cell companies or by 3GPP or any of the technology providers is safety. Have there been any health studies done on these frequencies and deploying all of these millimeter wave small cell technologies in cities? Because if I'm not mistaken, isn't microwave like really high frequencies and that's how you cook food? I would like to think that they're going to do some health testing on these things as well, but who knows. It's great for big cities where congestion on 4G is a problem and where multipath is a problem, but it does require all of those radios. So you're going to see a lot more of those cell tower radios just filled with antennas. And it takes, I think, 4 times as many to provide the throughput that they need. For us, this 5G technology is a good congestion avoidance scenario because it frees up all that 600, 700 megahertz bandwidth that 4G is currently using. And I think 4G is going to kind of meld into that, and so we're going to be using 607 megahertz up to 2.9 gig, and then all of the higher congestion, like the metropolitan areas where they have need for small cell, and a lot of them is really going to free up that lower frequency space. And that's great for us, especially for us broadcasters, where we need to have better connectivity to the cells so we can deliver audio and video at the higher bit rates that we need to transmit at. So as far as we're concerned, we don't care what network it is. If it's an IP network and it delivers an IPv4 or an IPv6 address, we can connect to it, we can use it, we can send data across it, and we can help you guys do broadcast. So we're all for more bandwidth, no matter what frequency it's on or what network it's on. So we're pretty excited about the technology. Now, I'm not a network engineer. I can't really tell you how these technologies are going to work. I just know that it's not deployed yet, and we're kind of waiting with everybody else. And I'm reading every day about all these press releases about what tests are being done and what providers. It's just a wait and see at this point. So for us, since we're IP agnostic, we have a whole Comrex Internet of Things, is what we like to call it, because we've actually gotten away from using circuit switch data services, POTS and ISDN, because I don't know if you've noticed, if you ever order like a VoIP phone service from the cable company, one of the first things they'll do is they'll find your old copper and they'll pull it up and they'll take it with them. They did that to my grandmother and she was not happy at all because she didn't have her dial tone phone anymore, her real, analog. Oh, it was like pulse, it was rotary, which is nuts, but I finally got her on something new. So they will pull copper. So it's all about Cisco routers and switches and hubs in the central office. So we don't make a POTS codec anymore. We don't make an ISDN codec anymore. We're all about packet switch data services. One of the things that we just introduced at NAB is something called Earshot. Since we don't make any, we currently make some POTS hybrids, we don't make our TCB2 autocoupler. And one of the things I was finding is as I was going into television stations, I would see 30 of our TCB2 autocouplers, and they were using them for IFB. And I'm like, 30? That's a phone line for every single autocoupler. So you would dial in, and it's basically audio in, and that's how you would listen to the audio over a phone line. That's like $3,000 a month in phone bills, or more. And if you have long distance on the service, it's even more. So a lot of television engineers were telling me that they're being eaten alive by phone bills because they keep on going up. So I asked the engineers to build me a voice over IP autocoupler since we weren't making the TCB2 anymore, and that's kind of what this is. The nice thing is you get a low-cost voice over IP phone line on an Ethernet cable, plug it in the back. Up to 30 people can dial into this box. It has 4 inputs. 30 people can listen to those simultaneously. So you can dial in on the regular cell network, or you can use the Field Tap app, which you see up there, using the 4G data or the Wi-Fi on your phone, and you can get 15 kilohertz audio out of those 4 inputs. So it's a nice little voice over IP autocoupler. When I first proposed it, I thought it was just kind of a boring, stupid idea because these are just boring, stupid boxes, but it saves a lot of money. To pay for itself in probably about 6 months, especially if you've got 10 autocouplers on phone lines. And it's just one of these things that's going to be dependent on internet connectivity. We introduced 2 new IP audio codecs as well. Access NX is going to be replacing our Access rack mount, which we have sold a lot of, and they're all over the world. In fact, our biggest customer has probably 2,500 access units, and it's the BBC. And it's been really good for us. But all new hardware, because we have a new hardware platform with a more powerful processor, and there are 2 products that will be coming out of that. The Access NX rack is a single access. It has an AES-67 interface. It also has analog and AES-3 connections on the back, and a new web GUI, which I can't show you because I'm not going to pay $79 for exhibitor Wi-Fi in the building. Sorry, otherwise I'll show you back in the exhibit hall. But it's a new HTML5 interface. We really needed to get away from the Flash interface that's on a lot of our products because everybody hates Flash. Everybody's nodding their heads because I know you all hate it. Adobe hates it, and they make it. So we needed to do something. So it's a nice, clean HTML5 interface that you can open up on your cell phone or on any browser, and you don't have to stupidly download Flash on every device you have. The other one is Access Multi-Rack. Access Multi-Rack is interesting because it's actually 5 access units, 5 stereo access in a single 19-inch rack mount. So you've got analog in, analog out, you've got AES-3 in and out, and then, and that's for the first channel. 2 through 5 would be on an AES-67 connector. I don't want to put you on the spot. You are a dead ringer for my brother, and it's freaking me out because you look exactly like him. So if I keep on looking at you and going, sorry. So Access Multi-Rack should be shipping a little bit later this year. I'm thinking in December, but it's basically AES-67, so if you've got Axia, WheatNet, anything that's Ravenna-based, plug it in and you're good to go. a little bit of configuration stuff you've got to do. You can also use field tap with these as well, and you can use it with BrickLink and our existing access. Mainly because 4G LTE is actually really affordable and the plans keep on coming down. We know that a lot of people are using access and BrickLink for STLs, and you might have wired service going out to your transmitter. But DSL, broadband cable, they're all prone to failure. All of my units at home, I keep on getting little buzzes on my watch telling me that my internet at home is down, and it's driving me nuts. So I can't get into my access or my latch out or any of my stuff. But we have a new device called the Comrex Connect Mode. And you can buy the AT&T or the Verizon or the international version. You can actually connect it into the USB on the back of a BrickLink, on the back of an access, and set it up to act as a failover. So if your wired connection goes down, it'll automatically start sending data on 4G LTE to connect to the other device. So it's using crosslock to manipulate this, and it's something that we felt was important because you need to be able to stay on the air. If somebody takes a backhoe and digs up your Ethernet or your fiber.
What's the cost?
I'm sorry?
What's the cost?
It's $475 for the modem, and then whatever your data plan is, you just take a SIM, you stick it in there, and then as long as you update your units to 4.0 firmware, the BrickLink and the Access, you just go in there, and it's actually 4.3 is the firmware that has it. It's on our website, Device Manager. It's available now, and off you go. Now on it, you have to have a Connect modem for the BrickLink, but any of our supported modems, like AT&T or a Verizon modem off the shelf, you can use those as well. And you can also use multiple modems on your access because you've got multiple USBs on there. So that's kind of a cool technology that we've just introduced. So it just gives you another backup. And it also sends you a contact closure to either device to let you know, give you a tally light to let you know that you're on 4G LTE. Really like that. When we bring out the Access NX, should be in December, hopefully before, you're going to be able to get something called a HD Voice Direct modem. It's a voice modem that you can put on the back of an Access NX. And when you take your handy-dandy smartphone that is really a smartphone that has HD voice, you can make a regular call to a regular cell number, and in this case to that modem, and it will deliver AMR wideband high-quality voice to your access. So now your reporters don't have any excuse. Unless I lost the number is the excuse. So they just dial the phone number, it answers, auto answers, and it's doing 7 kilohertz audio through the cell network. Not data on the phone, through the cell network, because it's using voice over LTE in that network. I don't know, I'm sure everybody has a smartphone, and if you don't, these are the greatest things ever. They all have an audio algorithm on there called AMR wideband, which is 7 kilohertz. So when you call your mom and she pulls up her Verizon phone and it sounds like you're in the same room, it's using that AMR wideband codec. And so we're going to be the broadcast-facing interface for that. The other product that is taking advantage of the public internet is something called Opal. And I'm sorry this is turning into a commercial, but it's technology. It's really cool. And we'll talk a little bit about it after I play this little video.
Yeah, man, it's good to hear your voice. The Warriors were massive last night. I mean, Steph was en fuego. He could not miss anything. I'm connected.
Oh, I hear you loud and clear, man. Yeah, it sounds like you're sitting right next to me in the studio.
It feels that way.
Level's good. Sound good? Perfect. We'll get you on the show right after this break. good was it to see the Warriors break their 2-game losing streak?
They needed a win more than anything else, so this was just huge. It didn't really matter how to get it.
Donald, my man, that was great, man. Thanks for coming on with me and Greg Papa on the Afternoon Delight 95.7 The Game.
It's my pleasure, man. This is so easy, brother.
We became aware of this technology called WebRTC, which was being built into common web browsers. A consortium between Google, Zype, which is Mozilla, and a few others, including Apple and Microsoft, believe it or not, got together and said, this could be a great new communications platform to enable web browsers to connect to other web browsers to deliver audio, video, and interoperability for things like ordering and communications. Especially great for customer service, like when you go onto the power company's website and somebody can pop up and talk to you and help you with payment or tell you that your power is going to be back on in 3 weeks or whatever. So WebRTC basically stands for Web Real-Time Communications. And if you have one of those common web browsers, whether it's Mozilla Firefox, Google Chrome, Opera, Microsoft Edge, and I think there's a few others. It has G.722 and the Opus coding algorithm in it. It also has VP8 and H.264 video coding algorithms in it as well. And there's also a communications engine. So there are 3 separate engines built into your web browser. So if you've ever noticed there's Google Talk or Mozilla or Firefox actually had a little thing that it was sponsored by Telefonica, where you could actually make a call to somebody else's web browser, you send them a link. Essentially, we took that technology and made it into a broadcast-facing interface. The big difference being that it's not using a third-party server like Skype. It's actually, our Opal box is the server. So you're making a peer-to-peer connection. It's secure because it's doing a SSL certificate exchange between the devices. And then once that happens, it is peer-to-peer direct connection. So you actually create a customized web link. It's actually generated in the device. You send it to the guest, and like Donald Foyle did, you just clicked on a smartphone that has that web browser, and it just makes a connection to the device, gives you a connect button, you hit connect, and you're talking back and forth. The only other thing you have to do is give it permission to use the microphone on your device, because that's what web browsers do. And then once you've done that, it's 15 kilohertz audio back and forth. Opal actually supports 2 callers at the same time, so you can actually have 2 separate callers on at the same time, or in different studios. You just have to provide a mix minus to each of the inputs if you want them to hear each other. But it's a pretty exciting technology, and if there were some forward-thinking technology company out there that wanted to exploit the video portion of that would probably be a really cool thing too. I don't know who that could be. Somebody will eventually. But WebRTC was actually touted as something that's going to change, and it is already starting to change the face of modern communication on this planet. We're already starting to see regular POTS phone lines go away. Anybody had totally gotten rid of a POTS line in their home that's strictly cellular? Yeah, I'm just about there too. So WebRTC is a really cool technology, and we're pretty jazzed about it. So those are all of our Comrex little Internet of Things that are leveraging all of the most widely deployed data infrastructure on the planet, which is the public internet. And we're going to continue making cool products and exploiting these technologies. Happy to answer any questions you have.
Just a minute before we're going to. Any quick questions?
Just add this comment on T-Mobile is rapidly rolling out the 600 meg stuff, because I've got 3 or 4 miserable days at an AM site where they're hanging big 50-foot long antennas on the tower.
Oh yeah.
So they're rolling that out. I don't know if they got anything to talk to it yet. But
Yeah, they've already started to deploy in some sections. I know one of the stations I work with, they're deploying in the Youngstown area, And luckily, our translator does not have to change frequency. They think. They think. But we'll see. Anything else? Okay, I'm starting to get hungry. It's lunchtime. Thank you, Chris. That was a good presentation. Luncheon and showcases across the hall. Make sure you've got your business cards in for the afternoon prize.